Okay, hello students. I would like to solve problem number 14 and 12, and there is one more, I think, should be 15. So last time in the class I tried to solve almost 11 problems, but so that we wanted to get ready for the test, I want to make sure you guys get an idea how to use Pythagorean identities and prove left equals right. So let me start with this is the left and the right. Begin with the left, so I'll call this as the left side, left hand side, and we need to prove that it's cosine minus sine x and cosine plus sine x. So the best thing is, because we are using Pythagorean identities, we are not using double angle formulas. So we'll try to change this tan x's, so this will be same as, so 2 twice sine x divided by cosine, then this will be 1 minus sine square, because there's a tan square, and cosine square of x. So let me keep this exactly the same. It's already in the form of cosine. Now, because there's a cosine square, we need to have the common denominator, multiply cosine square and divide also by cosine square, and let's write whatever the left. So this will be 2. Okay, now we have the common denominator, which is cosine square of x. So this is cosine square x minus sine square x. Now next step is that we are going to use keep, change, flip, keep and change and flip. But when you do this, let's see how, before, what do I do? Do I keep it exactly the same, or okay, at this time what I'm gonna do is this will be 2 sine of x divided by cosine x. So I keep the numerator exactly the same and flip the denominator. So the cosine square will be in the numerator, and this will be down. So you can see this one has cosine square minus sine square. So somehow I want to see if it is possible to get a common denominator here. This cosine square you can write as 2 of this. So that means I can write it as cosine square of x and plus another cosine square of x minus 1. Okay? So I write twice, and the reason is this will give you 1 minus cosine square of x is sine square. So if I switch the order, that is cosine square minus 1, then this will be minus sine square. So in place of this red one, we put it as 1 over, this will be red color, which is minus sine square, this cosine square, and this will be minus sine. And the reason is you want to have the same common denominator. Look here. Now this cosine x crosses out with one of the 2 cosines x. There are 2 of them, one of them goes away, and what I'm left with is, so you have 2 sine cosine x. So it has the common denominator, which is cosine square of x minus sine square of x, and the top one will be 2 sine x cosine x. So 2 sine x cosine x plus 1. So this is the left side. The question is, can we get directly from left to right? And for that, we need to know that 1 can be replaced by, so this becomes, in place of 1, you can use Pythagorean theorem and say, okay, that's cosine square of x plus sine square of x. So, and this I'll write, so this is split into cosine square, so cosine square here, plus 2, I'll write cosine first, and then the sine, and then plus sine square. So these two, they add up to 1 because of the Pythagorean identities, and they divide by divided by cosine square of x minus sine square of x. So the numerator will be a square plus 2ab plus b square. So we can write this as, so this will be equal to cosine of x, or let me show, so let me write this here, up here. So that will give you cosine of x minus, plus sine of x the whole square. And then the denominator is of the form difference of square. So this is like a, so this part is a, and here this is b, right? So a squared minus b squared is a plus b, a minus b. So we can write cosine of x plus sine x. So this, and cosine of x minus sine. Okay? So there are two cosine plus sine, and this is a single, this is one. So this whole thing crosses out one of them. And then that's how you're left with cosine x plus sine of x divided by cosine x minus sine of x. Okay? And then we are done. Now I want to show the problem number 13 on the other side. So it's ready right here. Okay. So this one is 10, so you can see the form, but you need to have the answer as 1 plus secant x plus cosecant. If you see this part, we can always think of 1 plus secant is 1 over cosine, and cosecant is 1 over sine, and then if you multiply by cosine and sine up down, cosine and sine, and cosine sine, you end up getting 1 plus cosine of x. So if we can figure out that this is, if we end up getting this whole thing, and then we can prove that this is going to be the left equal to the right. The best is replace sine as 10 as sine x over cosine of x, divide by, this is 1 minus, cotangent is cosine over sine of x, plus again cotangent will be cosine x over sine of x, and tan is sine over cosine. Okay, now let's simplify. There's a sine x here, so I need to multiply sine x, multiply and divide by sine x. And there's the cosine, so multiply and divide by cosine. So this will be main division line is this one. So this stays the same, and this will be sine x minus cosine x over sine x. And this side, cosine x over sine x will stay the same, and then the denominator is cosine of x, and it's cosine minus sine x, right? Now we need to use keep change flip. So this so the numerator will stay the same, that is sine x over cosine of x, and you flip this, so this sine x will go up, and then this will stay down, and then same thing, keep the numerator exactly the same, and switch the division sign, and flip the denominator, so that will be cosine x over, okay. Then, now, if you see this, this cosine is the same. This factor is the same, but then there's additional cosine x here and a sine x here. So we need to have the common denominator. To have the common denominator, we'll have to multiply this sine x, which is right here, multiply sine x and divide sine x. Okay? And because there's a cosine here, the red one, so you multiply cosine of x. Okay? And in case there are three of them, sine, 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 so that will be sine cube. Now I'm going to write sine x and put this one, and there's a reason why I do this. And the common denominator is this whole thing, sine of x, cosine of x, and then sine x minus cosine of x. Okay? But then this is plus, there are three of them, three cosines, so cosine of x, and put it. And you can see this is of the form A. This is the 3 here, and this is b. So we can use a cube minus b cube. So what's a cube minus b cube? So a cube plus b cube is a plus b, a square minus ab plus b square. So we'll use this here. So I'm going to wipe this off right on top. So this will be equals main division line. This stays the same, sine x, cosine of x, and then okay. So it is a cube plus b cube is a plus b. So the first part is a plus b. That is the red color. So it is the sine of x plus sine of x plus cosine of x. The blue color. And then there is a square, so square the sine x, so this becomes sine of square. Then you multiply the 2 times, no, so it is AB, so the A is sine of x, cosine of x. And then the square is cosine square. Okay. I want to show, make sure, did I copy the question? Let's see, there was 1 minus 10. There is some mistake I think I'm making. One minus 10 square, correct? There is a mistake. Oh, you're right. Now look at the mistake. So this was sine x minus cosine x here, sine x minus cosine, and this is cosine minus sine x. So we have to flip this. So that's the mistake I did. So because this is sine x minus cosine, I'm going to change this cosine minus sine x to sine x minus cosine. I did do that, but I forgot to change the minus sign. So this should be minus, this is minus, and we need to use a cube minus b cube, and this becomes plus. Okay, so when you do this, this becomes minus here, and this becomes the plus. Okay, so I hope, yeah, the reason is if you have b minus a is same as minus of a minus b. What is the reason to change is this was sine x minus cosine x, and this was cosine minus sine. So I need to have the same sine x minus cosine here. So I switch this, which is already done here, but at the same time, if I switch this, this should be sine x minus cosine. I'm sorry. Okay, so hope that makes sense now. I think I forgot about. So this, the reason is you can see this goes away, and these two things, sine square plus cosine square gives you 1. Right? And then if you want to get the right side is, so best is we divide all of them, all three can be divided by, so this, we can divide all of them by sine x because we need to have no sine x cosine in the denominator, so it divide sine x cosine of x, divide sine x cosine, divide sine x cosine. So this will cross out. And you end up getting this piece 1 over sine x, 1 over cosine x plus 1, right? And that will give you, by reciprocal identities, this is cosecant of x, and this is secant of x plus 1, and that is the, and the last one that I wanted to show before I finish this is one more, where is it? Oh, yeah. There is one more 15, problem number 15. I think the one that we did before was 14. So this was 14. You can always check your assignment. So this is y 1 minus 3 cosine of x minus 4 cosine square of x divided by. So we need to know why this is equal to 1 minus 4 cosine of x divided by 1 minus cosine of. Okay, so if we start with the left side, let's begin the left side. This looks like a quadratic, and there's a cosine square, there's a cosine of x. So I'm gonna write this this way, 4 cosine square of x first, this way. So that's the left side. And I'll take minus out, so undo, if I try undo distributive property, we can write this as cosine square of x minus plus, because there's a minus out, so it becomes 3 cosine of x, and this will become minus, so, okay. Now the numerator, instead of, we can work separately on this, just to show you want to know what is this. So separately, I'll try to show, if I plug this with cosine of x equals, if I put a p, some variable, this becomes 4p squared plus 3p and minus 1. So we can easily factorize that. And how do we factorize this? So 4 times 1 is negative 4, and you can split this negative 4 as 1 and 4. And because there's a plus 3, this will be plus and minus. So we can write this as 4p squared plus 4p minus p minus 1. And you can see we can take 4p outside. So this will be p plus 1. And here minus 1, it is p plus 1. So you get 4p plus minus 1. So this is a regular factorization. And you put back whatever the cosine x is. So 4 cosine x minus 1 and 4 and cosine x plus 1. So we'll replace this numerator as minus, so the numerator is 4 cosine of x minus 1 and cosine of x plus 1. The denominator sine square is same as 1 minus by Pythagorean identity, which we can apply difference of square like this, 1 square minus this. So this will be of the form a square. So this is, So this is like A and that's B. This is like B, A square minus B is A plus B, A minus B. So it is 1 plus cosine of x and 1 minus cosine of x. That way, these two are the same. So this crosses out and you get 4 cosine x minus 1. There it is, 1 minus cosine of. So the confusing is only how to get this, write this into the quadratic form and use this trick and you can get the answer. So that takes care of, this is the right hand side. I think the other problems are pretty much easy and you don't need my help. So these are the only 3 problems I wanted to help. So get ready for the test tomorrow. And complete this. I need the packet, okay? So there are all together. The back side is last. You have to match it. So make sure you complete the whole packet until 19 problems. Bye.